RF layout provides the designer with the capability to route and manage RF signals fast and accurately, with a dedicated object type which we call the RF meander. The meander is a highly configurable object and allows the user to seamlessly route and manage complex signals for RF design. The meander uses the same sophisticated clearance models as all other RF elements, allowing the user to control clearances on the same and adjacent layers as the meander is inserted. To optimize the performance of the RF circuitry, there are also powerful tools available for inserting ground vias around the RF signals. So let's take a quick look at RF layout and the meander routing capabilities. The meander object is highly configurable and allows the user to taper up and down on the fly. The meander automatically adjusts its width up or down as it connects to other RF elements in your design. The meander can be routed on any layer, and to transition between layers you simply double click and continue with the meander on the new layer. If you change your mind while routing the meander, you can backspace any number of segments, even back through the vias and take another path to the target. The meander supports a variety of object types, such as mitre, radius and free radius. The bend type can be changed at any time during the meander command and can be mixed within the same meander object. When using mitered bends, the mitre percentage is controlled from a user-defined table. This allows the mitre percentage to automatically adjust itself based on the angle the meander is inserted, thus creating the optimal mitre on the fly based on your preferences. Observe the mitre percentage field while this meander is being inserted, and notice that it updates on the fly as the angle changes. To make connections as smooth as possible, the meander has the option to automatically add a smooth path between two connection points. With the smooth termination option enabled, all you need to do is move the cursor over the target pin and an optimal S-shaped meander is inserted automatically. To insert a meander with a fixed length, you can use the serpentine option. This will insert a serpentine shaped meander based on the desired length. The ghost shape of the meander updates on the fly as you enter the parameters. There are several ways to modify existing meanders. You can modify individual segments of the meander or the meander as a whole based on the selection. To modify the width of individual segments, simply double-click the meander segment to invoke the parameters dialog. Use this dialog to edit the start or end width to create tapered segments or change the width of entire segments. You can also change the width of multiple segments at the same time by window selecting the multiple segments. To interactively edit the meander, invoke the Edit Meander command and move segments as you like. When moving segments over each other, the command will snap them into place and remove redundant segments. The Edit command also provides options to lock bends during the edit operation, to allow seamless editing of meanders at arbitrary angles. The meander uses the same clearance handling as all other RF elements. This means that you can define clearances that will keep traces and other design objects away from the circuitry, not only on the layer where the meander is inserted, but also on adjacent layers. While adding this meander, you can see how the dynamic plane data updated when I added each segment. I will now set up a Z-axis clearance for the layer below the meander. This is to keep traces, planes and vias away by 40 mm. When player routing away from this component, you will notice that the trace is obviously not allowed to cross the meander on the same layer. Now if I add a via in player route on the layer below the meander, you will also see that the trace is still not allowed within 40 mm of the meander. This is a very efficient way of making sure that the traces that could disturb the circuit performance are always kept a safe distance from the RF circuit. A common task when optimizing the performance of the RF circuitry is to add ground vias around the RF signals. And in this example I will demonstrate both stitch contour and stitch shape methodologies. As the name indicates, stitch contour is used for adding vias along the contour of design objects. You can select a mixture of objects and in this demonstration I'm selecting a meander and a few elements from the mixer circuitry. 2 rows of vias are then connected to ground around the selected objects. One really useful option when using stitch vias is to group the vias with the objects. The group will later allow you to move all the vias together with the objects as a single unit. You can still move or delete individual vias that are in the group. If you need to flood the whole plane with vias, you can do this using the Stitch Shape option. Simply select the plane shape, set up your parameters and hit Apply. The plane will be flooded with vias in seconds. You've now seen that by using a dedicated object that understands design requirements for RF, and also by combining standard RF models and components with intelligent routing for RF, you can safely design and protect the RF circuitry as a whole.